Hello everyone and welcome to another lecture of Power Systems 2 with AKtU code as KEE601. My name is Kitty Tripathi and I am faculty of Electrical Engineering Department, Babu Banarsi Das, Northern India Institute of Technology, Lucknow. Let us begin with the fault analysis. In previous lectures, we have already discussed about symmetrical components and how we draw sequence network for various elements which are used in power system. Now, let us move towards the main objective of solving a symmetrical network or deducing a symmetrical network, why we are doing it and how helpful it can be in analysis of power system. So, let us begin. Okay. So, before beginning, let us state the purpose of fault and what is exactly a fault, and in power systems how do we classify them. Okay. तो फॉल्ट, अगर हम फॉल्ट वर्ड यूज़ कर रहे हैं तो फॉल्ट का क्या मतलब है, ऐसी कंडीशन विच इज़ नॉट अकरिंग नॉर्मली, दैट मीन्स सम काइंड ऑफ एबनॉर्मेलिटी इज गोइंग अराउंड, देन वी कॉल्ड अ सिस्टम इज अंडर फॉल्टी कंडीशंस. ठीक है, तो अ पावर सिस्टम में अगर कोई फॉल्ट आ रही है दैट मीन्स देयर इज सम काइंड ऑफ फेलियर विच इज़ लीडिंग टू सम एबनॉर्मल कंडीशंस and there is flow of current which is not normalized. So, when we are talking about abnormal conditions, it may be change in voltage, it may be change in frequency, it may be change in current. Anything which changes abnormally can be termed as a faulty situation in a power system. ठीक है. So, when we talk about a generalized situation, कि अगर power system में कोई general fault word हम use करें, that leads to any of these changes such parameters like current, voltage or frequency. ठीक है, तो इनमें कोई भी abnormal conditions का change आए then we say a fault has been occurred. So, how do fault occur and why do fault occur? Then only we will move towards how do we analyze it, correct? So, let us think about what are the various reasons which can lead to a faulty situation in a power system. So, in generally what happens that there are larger number of insulations which are around there in the entire power systems around the equipment and so on. So, one of the prominent reason is we have some kind of insulation failures in any kind of equipment. There can be more reasons like lightning stroke, which is a very common occurrence in rainy seasons. What happens is a sudden stroke of light which is on the overhead transmission line can initiate a flashover voltage all of a sudden, and this can accidentally cause faulty operation in the power system. What are the various other reasons? Various others, apart from insulation breakdown, there can be various reasons like failure of a particular device, right? Maybe some short circuit occurred, a wire has been broken or any connection got broken. So, there are a particular bird, sometimes we always see a bird comes and sit, and when it tries to flow its wing, it suddenly what it does is touches the two phases of the transmission line and it can create a short circuit. So, there are various such factors. Falling of trees also one of the common issues if a windy weather is occurring, or all of a sudden a tree which is quite inclined around the roadside where transmission lines are passing by and it fell on it. So, there are large number of things which can lead to fault in a power system, right? अगर अब हम इस behavior को किसी map या diagram के through express करने की कोशिश करें तो let us understand when we do a power system analysis, why do we need analysis for such systems? To know what exactly conditions are coming when their fault is occurring. Why do we want to know? That is because until and unless we know what the values are, how will we find a particular solution or a remedy for it? अगर हमें faulty situation से अपने equipment को protect करना है तो हमें पता भी तो होना चाहिए कि कितना voltage, कितना current का excessive flow होना शुरू हुआ, right? So, that is the reason we try to do analysis. So, let us talk about analysis portion a bit more. When we are doing some analysis in a particular power systems, we generally divide it into two segments. First is called as steady state analysis and second is called as dynamic analysis. As we know the word term steady state, that means we have reached the value of the network is in steady state condition, and then something we are trying to analyze, then at that kind of analysis comes under steady state analysis. And when dynamic means change. So, when there something is changing at the time of transient or any change in load, when we are doing change in load, major shifting of load, such kind of things happen at that particular instant when we want to study the entire power system and its behavior, then we say it is a dynamic analysis. ठीक है, जब हम स्टेडी स्टेट एनालिसिस पर आते हैं तो दो तरह की एनालिसिस अगेन हम डिवाइड कर रहे हैं. एक है जब नॉर्मल कंडीशंस हैं और हम स्टेडी स्टेट एनालिसिस करना चाहते हैं पावर सिस्टम की, और दूसरा है जब सिस्टम में कोई फॉल्ट अकर हो गया हो और हम फिर करना चाहते हैं सिस्टम की एनालिसिस. ठीक है, नाउ अगेन लेट अस सब डिवाइड बोथ दीज थिंग्स. जब नॉर्मल कंडीशन हो या फॉल्टी कंडीशन हो और हमें स्टेडी स्टेट कंडीशंस में इंटायर पावर सिस्टम की एनालिसिस करनी है, देन वी अगेन हैव टू मोड्स. वन इज वी आर डूइंग एनालिसिस व्हेन द सिस्टम इज इन बैलेंस्ड कंडीशन, एंड वी आर डूइंग अगेन व्हेन सिस्टम इज इन अनबैलेंस्ड कंडीशन, बैलेंस्ड एंड अनबैलेंस्ड कंडीशन. नाउ व्हाट इज एन अनबैलेंस्ड कंडीशन? Unbalanced condition means the phase sequence and the phase difference between all the three phases is not 120, 120, 120 anymore. ठीक है, so this is what the entire analysis picture goes around in the case of steady state analysis. When we are doing it dynamically, we have again two situations. Dynamic conditions में analyze कर रहे हैं, जब changes हो रहे हैं power system में, maybe there is a change in load, maybe there is a change in voltage, whatever we are trying to do, the system is still in normal condition, or it may happen the system comes under certain amount of fault and that fault persisted, and so we have to analyze. ठीक है, these are the two modes where we completely analyze a particular power system. हाँ, एक चीज़ है जो हमें ध्यान रखनी है, वो है जब हम स्टेडी स्टेट में सिस्टम को एनालाइज करते हैं तो वी हैव टू मेक श्योर दैट वी अज्यूम दैट इट इज़ एन एंटायरली अ लीनियर सिस्टम. द सेकेंड assumption when we analyze it, we make it that we have to do the values at instantaneous amount of time. It is being done instantaneously. Whereas when we are talking about dynamic, it can be balanced, it cannot be balanced, it can be linear, it cannot be linear, and while solving we tend to solve it in time domain. So, let us move further. Now, since we have addressed the factor कि हमें power system में analysis कितनी categories में करनी है, normal conditions and abnormal और faulty conditions. Normal conditions and abnormal conditions में भी हमने कहा balanced और unbalanced का situation आता है. So, now if a system is running in a normal condition, then we only have to worry about stability and error, right? तो स्टेबिलिटी के लिए हम सेपरेटली एक मॉड्यूल को डिस्कस करेंगे जिसमें हम पावर सिस्टम की स्टेबिलिटी पर बात करेंगे. राइट नाउ लेट अस फोकस ऑन एबनॉर्मल कंडीशन, दैट इज अ फॉल्टी कंडीशन. सो लेट्स डिवाइड द इंटायर फॉल्ट इन अ पावर सिस्टम इन कैटेगरीज. सो व्हेन वी try to categorize fault in a power system, we divide it into generally two categories. One is called shunt fault, other is called series fault. ठीक है, नाम से ही अपना स्टेटमेंट क्लियर हो रहा है. द फॉल्ट व्हेन अकर्स इन अ शंटेड पोजिशन और इट इज अकरिंग इन अ सीरियल सीक्वेंस, राइट? सो लेट्स टॉक अबाउट बोथ ऑफ दीज फॉल्ट इन डेप्थ. let us first quickly jump on to serial fault and talk about it. Serial fault में क्या हो सकता है? तो possibility serial fault में क्या है? ओपन सर्किट होने की. अब serial faults में ओपन सर्किट होने की possibility है, तो what are the chances? The chances are either a single phase या one conductor is in faulty position and it gets open circuited, or maybe in three phase two systems are open circuited. You will ask why not three? If there is three phase, all the things are open, that means it is not under operating condition. We are talking about operating condition में क्या हो रहा है. तो operating condition में अगर series fault आती है तो दो चीज़ें हो सकती हैं कि थ्री phase में से या तो single phase का conductor open circuit हो जाए, कहीं faulty condition की वजह से conductor break हो जाए, या फिर दो फेज में ऐसा हो जाए. So that is what we have written here, that is series fault is basically divided into two parts. One is called as one open conductor fault and other is two open conductor fault. Two conductors are at open circuited condition. Now let's talk about the shunt one. Shunt fault occurs when there is some short circuit. Then only shunt positioning will be happening, right? तो जब हम किसी सर्किट में किसी पावर सिस्टम के रिप्रेजेंटेशन में अगर कहीं शॉर्ट सर्किट हो जाए, देन इट लीड्स टू शंट फॉल्ट. नाउ व्हेन वी कैटेगराइज शंट फॉल्ट, वी कैटेगराइज इट इनटू टू पार्ट्स. वन इज कॉल्ड एज सिमेट्रिकल फॉल्ट and other is called as unsymmetrical fault. What are symmetrical faults? In symmetrical fault, what happens is, even after the occurrence of fault, the symmetry of three phase is not disturbed. That means the magnitudes are in same phase, are in the phase difference of 120, 120, 120, and they are in the same sequence as the supplied one. So there is entire symmetry. Or and when can this happen? It can only happen जब तीनों ही फेज में एक साथ फॉल्ट आ जाए, तभी सिमेट्रिकल कंडीशन पॉसिबल है. सिमेट्री तभी हो रही है जब जो चीज़ भी हो रही हो तीनों फेज में इकट्ठा हो रही हो. एंड व्हेन एनीथिंग इज हैपनिंग इन ऑल द थ्री फेजेस, देन ओनली वी से इट इज़ अ सिमेट्रिकल फॉल्ट. थ्री फेज में तो ऐसा ही पॉसिबल है कि तीनों सिमेट्री तो तभी आएगी जब तीनों में इक्वली कोई काम हो रहा होगा. दैट मीन्स सिमेट्रिकल फॉल्ट हैज़ ओनली वन सब कैटेगरी विच इज़ कॉल्ड एज थ्री फेज फॉल्ट, और वी कॉल्ड एज ट्रिपल एल फॉल्ट. All the three lines are short circuited simultaneously. It may happen that they are only short circuited together, or all these short circuited are connected to the ground as well. This is the rarest occurrence of fault and is of highest severity among all types of fault, right? Now let's quickly jump on to the unsymmetrical one. Now what is unsymmetrical fault? ऐसी fault जिसके occurrence की वजह से उस सिस्टम में सिमेट्री डिस्टर्ब हो जाए थ्री फेज की. दैट मीन्स देर इज नो लॉन्गर फेज डिफरेंस ऑफ 120, 120, 120 अकरिंग बिटवीन द फेज ए, बी एंड सी, राइट. अब ये कब पॉसिबल है? इट इज़ पॉसिबल फॉर थ्री सिचुएशंस. वन इज कॉल्ड एज LG fault, commonly known as line to ground fault. Now what happens in line to ground fault? Any particular line of three phase, any it may be phase A, phase B, phase C, any one is connected to ground. That means there is a short circuit occurrence between one line and ground. It is also called as single line to ground fault. ठीक है. Next, what can happen? This will lead to unsymmetrical conditions. Why? There is one phase which is behaving abnormally, rest two are not behaving in abnormal conditions. Only one phase has got short circuited, so it will lead to some unsymmetry in the alignment of 120, 120 phase difference between all the three phases, and hence it will lead to unsymmetrical fault. Second category जो unsymmetrical fault में आती है, that is LL fault. LL stands for line to line fault. What happens in this case? Any two lines of three phase system get short circuited together. एनी टू फेज ए बी आपस में शॉर्ट हो सकते हैं, फेज बी सी आपस में शॉर्ट हो सकते हैं, फेज सी ए आपस में शॉर्ट हो सकते हैं. कोई भी दो फेज आपस में शॉर्ट हो जाए तब भी तो अनसिमेट्री आएगी, बिकॉज सिमेट्रिकल थिंग्स आर नॉट हैपनिंग. ऑल थ्री फेजेस आर नॉट अफेक्टेड, ओनली टू फेज वॉज अफेक्टेड एंड दे गॉट शॉर्ट सर्किटेड, मे बी बिकॉज ऑफ द इंसुलेटर फेलियर, or maybe a bird is sitting around between both the lines of the phases, and it flows its wings and it get touched to both the lines. Anything can happen. A tree is fallen, both the conductors got, wind is blowing, both the conductors got touched at some point of the time, and this can happen, right. Lastly, it is LLG, or it is also called as DLG, line to ground fault or double line to ground fault. What happened in this case? Two conductors are short circuited, but now they are connected to the ground as well. That means the potential is equal to 0, right. So this case is happening when both the conductors which are under short circuited is also touching to the ground. Maybe again because of the failure of insulation, or the wire itself got broken down and got touched in direct touch with the ground. Anything can happen, So, in such cases unsymmetrical conditions arises and hence they are categorized under unsymmetrical fault. अब हम इनके occurrence की बात करते हैं, कौन सा सबसे commonly occurring fault है और कौन सा least occurring fault. So, see here we have mentioned the most common occurring fault is single line to ground fault. At maximum 70% of the time this fault is occurring. Less number of occurrence has of line to line fault. Approximately 15% of the fault in a power system is LL fault. More lesser occurrences of double line to ground, which is around 10% in a particular power system, and the least occurring fault is 3-phase fault, which is around 5%. तो ये order है occurrence का. When we talk about severity, the order is opposite. Top one 3-phase fault is the most severe fault, then double line to ground fault, then line to line fault, then single line to ground fault. In the terms of severity, this is the most severe fault, and the last one is the least severe fault, which is line to ground fault. So, this is the distribution of faults which can occur in any kind of power system. Now, let us move further and discuss a bit more about first symmetrical fault, and then we will move on to unsymmetrical faults. So, let us quickly jump, because there is only one category in symmetrical fault. So, quickly let us understand what it is, and then we will have some numerical explanation in other lectures. We will discuss it accordingly. So, let us now discuss about symmetrical fault analysis. What is symmetrical fault? कि तीनों फेज में एक साथ फॉल्ट आ जाए, सिमेट्रिसिटी डिस्टर्ब ना हो, बट फॉल्टी कंडीशन हैज अकर्ड. व्हेन कैन दिस हैपन? ऑल द थ्री फेजेस आर under short circuited. So, see here this diagrammatic representation shows that phase A, phase B and phase C is, see it is, this line is showing short circuit. What has happened? All the three phases are shorted together. Since there is equal fault current in all the three lines, therefore, the displacement of 120, 120, 120 degree in all the three phases are to be maintained, and in such cases the fault is symmetrical fault. Now, let us see what about the boundary conditions or the conditions which are being executed in case of symmetrical fault. Let us see the diagram once again. What is the diagram depicting? Phase A, B and C are shorted together. ठीक है, आपस में कनेक्ट हो गए हैं, तीनों फेज का पोटेंशियल डिफरेंस सेम हो गया है. देयर इज जीरो पोटेंशियल डिफरेंस, ऑल द थ्री आर एट सेम पोटेंशियल. दैट मीन्स व्हाट कैन वी राइट अबाउट द इक्वेशंस ऑफ वोल्टेज हियर? All the three phases are at same voltage level. That means VA will be equal to VB and it will be also equal to VC. This is the only thing which can happen because of the short circuit. What next? What about current? So, all the three current, you know what is the faulty current? This is a common current which is, you know, coming from IAC, IB is coming here, IC is coming here. All the three are now having this distributed current. Now, when we apply KCL here, what can we say? What does KCL say? At a node, total sum of incoming current and outgoing current is equal to 0. So, what can we write about it? That IA plus IB plus IC is equal to 0. So, this is the condition of boundary conditions for a symmetrical fault analysis. Now, how do we calculate? We have two methods. Method number one is we analyze it on the basis of calculating values for per phase. How can we do this? We can calculate per phase by quickly drawing a reactance diagram, use Thevenin's analysis and calculate and determine whatever the current is at wherever we want to know in the entire circuit. जैसे Thevenin theorem को अप्लाई करके हम कहीं लोड करंट की वैल्यू निकालते थे, सिमिलरली यहाँ भी सर्किट, इक्विवेलेंट सर्किट अगर डिड्यूस हो जाए, जो कि कैसे डिड्यूस होगा? रिएक्टेंस डायग्राम के थ्रू, विच वी हैव ऑलरेडी कवर्ड इन द प्रीवियस लेक्चर. इट विल गेट डिड्यूस्ड फ्रॉम देयर, वी विल ड्रॉ इट द रिएक्टेंस डायग्राम फॉर पर फेज. what next? We can determine the value of fault current by applying Thevenin's theorem quickly. The other methodology is through bus impedance matrix. We will discuss this in upcoming lecture. Now let's move on to the unsymmetrical fault analysis. The first case is the most common occurrence fault, which is line to ground fault. अब इसको हम दो पार्ट में डिवाइड करके स्टडी करते हैं. पार्ट नंबर 1, जब अनसिमेट्रिकल फॉल्ट हो रही हो और फॉल्ट के समय हमारे पास कोई फॉल्ट इम्पिडेंस ना हो बीच में. ठीक है, व्हाट डज दिस मीन? सो लेट्स सी दिस विद दिस हेल्प ऑफ दिस डायग्राम. व्हाट वी आर सीइंग हियर कि एक जनरेटर का इक्विवेलेंट डायग्राम बना हुआ है, 3 फेज जनरेटर का. ठीक है, फेज ए हैज़ EA एंड Z1, फेज B is having some Z1 or Z we can say simply, and it is also having Z. ठीक है, impedances are there for all the 3 phases. Now one phase got short circuited with and it is connected to ground. That means line to ground fault has occurred. तो हम लोग हमेशा एक कन्वेंशन लेकर चलते आए हैं इस यूनिट में कि फेज़ ए को हम लोग रेफरेंस फेज़ मानेंगे. तो जिस भी फेज़ में शॉर्ट सर्किट आया होगा उस फेज़ को हम फेज़ ए मेंशन कर सकते हैं. तो दैट इज़ व्हाट इज़ शोन हियर. हम फेज़ ए को रेफरेंस फेज़, जिस भी फेज़ में शॉर्ट सर्किट आया उसको रेफरेंस फेज़ की ही वैल्यू ले लेते हैं, उसको इंडिकेट कर देते हैं फेज़ ए, बचा वाला बी और सी हो जाएगा. नाउ व्हाट इज़ हैपनिंग, फेज़ ए में शॉर्ट सर्किट हुआ, इट इज़ गॉट कनेक्टेड टू द ग्राउंड. सी दिस indication of fault is mentioned here. Now what are the boundary conditions here? As soon as the short circuit occur, there is no impedance connected between this line and ground. ठीक है, what will happen? The potential at this point will be equal to the potential of the ground, which is 0. That means VA will be equal to 0 is the first condition. What about the current? The current IA will become the fault current because that is the only phase where fault have occurred. That means IA is equal to IF. What about the other 2 phases? They will have no current. Why? Because this is the property of the current. It moves or flows where it finds least obstruction or least resistance. Current tend to follow minimum resistance path. जहाँ शॉर्ट सर्किट हुआ है वो मिनिमम रेजिस्टेंस पाथ है, तो बचे हुए दोनों जगहों पर करंट की वैल्यू हो गई 0. नाउ व्हाट विल हैपन टू दिस? हाउ आर वी गोइंग टू सॉल्व? वी कैन सी इट फ्रॉम दिस डायग्राम. We will use the equations of symmetrical networks which we have written. Now what do we say for a symmetrical network? These 3 equations, VA0 is equal to minus IA0 Z0, VA1 and similarly VA2. See what is happening here, unsymmetrical fault have occurred. So what are we trying to do? हम unsymmetrical fault को symmetrical components के through analyze करेंगे. यही purpose था हमारा symmetrical faults को symmetrical components को deduce करने का. तो यहाँ पर हम लोगों ने नेटवर्क इक्वेशंस लिखी हैं फॉर व्हाट? सिमेट्रिकल कंपोनेंट्स. अभी हम करेंगे क्या, हम लोग को देखो हम लोगों को क्या चाहिए, IA1, IA2, IA0, तो हम VA1, VA2, VA0 की वैल्यू निकाल सकते हैं. एंड हाउ आर वी गोइंग टू डू? जैसे IA0 वी हैव स्टडीड द फॉर्मूला 1/3 IA प्लस IB प्लस IC, राइट. सिमिलरली 1/3 IA प्लस लैम्डा IB plus lambda square IC and 1/3 IA plus lambda square IB plus lambda IC. पॉजिटिव, नेगेटिव एंड जीरो सीक्वेंस का कंपोनेंट हम लोगों ने पढ़ा था, रिप्रेजेंटेशन दिख रहा है यहाँ पर. नाउ व्हाट वी विल डू, वी विल पुट द बाउंड्री कंडीशन वैल्यूज हियर. व्हाट? B and C is equal to 0. What we will get here? IA0 is equal to 1/3 IA. Similarly IA1 is also same value and IA2 will also have the same value. क्यों? क्योंकि बची हुई वैल्यूज तो 0 हो गई हैं. So what can happen now? We got the values of IA1, IA2 and IA0. What we will do? We will substitute this value in all these 3 equations and we will write VA is equal to VA1 plus VA2 plus VA0, which we know is equal to 0. From here when we solve, we will get the value of IA. And why? How? Because we can get the value of IA1. अगर हमें IA1 मिल जाता है तो 3 टाइम्स IA1 कर दें. देखो यहाँ पर IA1 की वैल्यू 3 टाइम्स IA1 कर दें तो हमें IA मिल जाएगा. Substituting this in these equations with the help of the equation shown here, we will get the value of the fault current and hence we can determine what amount of fault is occurring. Similarly, when fault has occurred but with an impedance, अभी क्या हो रहा है यहाँ आई बी और सी में अब भी करंट ज़ीरो है, अभी भी आई बी ज़ीरो है, अभी भी आई सी ज़ीरो है, तो इस केस में भी आई ए वन इज इक्वल टू आई ए टू इज इक्वल टू आई ए ज़ीरो इज इक्वल टू 1/3 times आई ए. This is still happening. The only change is now V A is not equal to 0. See here, this potential difference has got equal to 0. That means V A is equal to I into ZF. V A will be I A into ZF. Now how will we determine V A and I A? I A का तो वैल्यू दिख रहा है, V A के लिए क्या है हमारे पास? This option is available. Again VA1 plus VA2 plus 0. सब्स्टिट्यूट करके सिमिलरली हम नेटवर्क इक्वेशंस के थ्रू ऑब्टेन करने की कोशिश करें तो हमें यहाँ पर फॉल्ट करंट की वैल्यूज़ मिल जाएंगी विच इज़ शोन इन दिस इक्वेशन. सी यार हमने यहाँ पर क्या किया है, अगेन VA1 VA2 VA0 लिया है. हमें पता है कि IA1 इज इक्वल टू IA2 इज इक्वल टू IA0 इज इक्वल टू 1/3 IA. ठीक है, हमें ये भी पता है कि VA इज इक्वल टू IA इंटू ZF. ये दोनों इक्वेशंस और ये तीन इक्वेशंस व्हेन वी सॉल्व इट टुगेदर बाय सब्स्टिट्यूटिंग वी विल गेट द वैल्यू ऑफ फॉल्ट करंट. द ओनली डिफरेंस फ्रॉम द प्रीवियस वन इज द इक्वेशन इज द एडिशन ऑफ 3 times ZF factor which comes in the calculation mode, and hence we can obtain the value of fault current in the case of line to ground fault. Okay, that is it for today's lecture. Rest other faults we will discuss in upcoming lecture. Thank you.